Hey folks, welcome back to another video. Today we're looking at question 863, all nodes distance k in binary tree. The way we'll be approaching this problem is by using DFS. So basically we can use DFS to go down k times, but we cannot really go up because we don't have any sort of linking from a child to a parent. So we need to create that linking by using a hash map. So let's get started with that. So we need a hash map. And since all of the values are unique within the binary tree, you could just use map integer to tree node. And basically, that takes you to its parent. You could also use tree node to tree node, but it's up to you. Let's call it child to parent. Is equal to new hash map. Awesome. Do we need any other data structure? Yeah. So let's initialize the resulting list as well that we need to return. We can use that later. New array list. Okay. Okay. And since we are using a DFS, we need a queue. Let's do that. So queue. Let's go with tree node. Queue is equal to new linked list. All right. So while, okay, so basically, where do we start off, right? So we need to get links between the children to the parent. So the way we go about doing that is like, let's just offer the root node within the queue. And then we have while queue is not empty, you keep iterating through it till you get a link between all of the child and the parent. All right, so what do you need to do? You need to do, let's get the size. So for int I equals 0, I don't think we actually need this. Okay, so actually let's do tree node current would be equal to q dot poll, right? And then if current dot left is not equal to null, then you add that link. So it would be child to parent dot put, you go current dot value, actually current dot left dot value to the current node, and then you offer that to the queue dot offer current dot left, and you do the same for right as well. And then yeah, awesome. So this should give you basically everything that you need. So basically like linking from the child to the tree into the parent. Once that is done, we can move forwards and backwards. So let's do BFS now, where we go to every, like the next level till we hit K. So let's do q.offer. So basically the queue at this point will be empty. So you can just go, you can put target in that, and then we keep, you take the target and then you move one level up, one level down until we reach K. And then we need a hash set because this is DFS. You need to keep a track of everything that we visited. So we'll keep a track of it using an integer hash set since all of the values are unique. So let's just call it visited is equal to new hash set. Awesome. And then for this, while k is greater than 0, or we could do like I is equal to 0 and then keep incrementing till it's equal to k or things along those lines, but simpler this way. And while q is not empty, you keep iterating. Awesome. So in this case, we need to know when we are moving from one level to the next. And the way we do that is by actually looking at the size. So when we've added something to the queue for a given turn, so that when we're adding new nodes, we don't count that in the same level. We need to do that by looking at the size of the nodes and just iterating through those nodes. And the way we do that is we get the size, and then we have a for loop for just those nodes. I less than size increment I, right? And then tree node current is equal to q dot pull. All right, so once we have that, we need to go left and then right. So let's do that. So if current dot left is not equal to null, and we haven't visited it before, so visited dot contains current dot left dot value, then you add that. You add that, so it'll be oh, you need to add that to visited as well. Visited dot add current dot value actually. Yeah, okay. And then you need to add that to the queue. So queue dot offer current dot left. Awesome. And then next up we have right. Okay, awesome. Okay, so we have done traversing downwards, so basically going to the left and the right node. And now we need to go to the parents, right? So basically, if child to parents that contains key current dot value. So basically, you're checking, hey, does this particular value have a parent or not? And we haven't visited that before. Visited dot contains child to parent dot get current dot value, and this will give us a node in itself, and then you need to get a value after that. So it's giving you the parent, but you need to get a value. So basically, you're checking if we haven't visited that before. That's awesome. So you add that to the queue. So queue dot offer. You offer the parent child to parent dot get current. No, current, no, child parent dot, yeah, current dot value. So this will give us a parent. Awesome. So once we have iterated through the entire level, we need to decrement k. That means, hey, like we have moved one level, so we need to do that again. So once that is done, the loop will break when we have moved by 10 levels, and then all we need to do is add the remaining nodes that are in the queue to the resulting list that we need to send back. Why do we do that? That's because we've already iterated k times, and everything that comes after that's there in the queue, that means it's at the next level, at the k level, and this takes care of everything that's below, so its children and its parents. So while queue is as long as it's not empty, you keep adding them to the result. So res dot add q dot pull dot value, and then you return res. Awesome. So I think that should work. Of course. Oh wait, it's a method. Let's try that again. Oh, wait, I made that mistake again. Okay. Compiling issues. All right, the first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity is of n since we are iterating through all of the nodes that are given to us in the tree. And the space complexity is also of n since we are using additional data structures to store the information that we care about. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. It definitely keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon.